Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra II class. Today we are going to continue our discussion with matrices, and we're actually going to talk about something really, really cool. I don't know why this is 12.3. Sorry, my boys. This should be Matrices Part 3. Sorry. Okay. So anyways, today we're going to be talking about the determinants of matrices. The determinants. Okay, determinants are a specific matrix value calculated through a specific formula. Determinants are used to find inverses and the area of any triangle. They are also used for something we're going to learn called Cramer's law. Okay? Cramer's law. Or Cramer's rule. And using Cramer's and these determinants, we can solve systems of linear equations with both 2 variables and 3 variables. But before we can find inverses or find areas or use Cramer's, we're going to have to know how to find determinants. So let me show you, because it's really simple. First of all, we're going to learn how to do a 2 by 2. This one is beautiful, guys. Remember, when you have a 2 by 2, you've got 2 rows by 2 columns, okay? And the formula for the determinants of a 2 by 2 is real simple. A times D, these two, multiply them, and then these two, multiply them, and it's the difference of those two. Literally. Literally. So if I have the matrix 5, 2, 8, 7, this is going to be 35 minus 16, which is 19. And that's my determinant. Literally, that's simple. I think that's even, I know for sure that's even easier than multiplying matrices, right? It's less confusing, man. So that's how you find the determinant of a 2 by 2. Sir. The determinant, like we said already, the determinant we're going to use for Cramer's to find area and or to find inverses. That's what it's for. Okay, no, thank you, my brother. Okay, so a 2 by 2 matrix is literally the difference of the cross products, if you want to look at it that way. It's this first one times this last guy, and then this guy times this guy. So it's term 1 times term 4, and term 3 times term 2. And it's the difference of those. That only works for a 2 by 2, unfortunately. I'm not trying to be sarcastic, but that's why it's for a 2 by 2 matrix determinants. Not for a 4 by 5 or any other kind, it's for a 2 by 2. Now, 3 by 3s. There are 2 ways to do this, okay? In case you see this later on in the future and you say, Morrow is wrong. No, I just decided to choose the easiest of the 2 ways. There is one way where I'll give you a brief explanation. You kind of eliminate these, okay? And then you put them outside of here. And then you find the determinant of this and multiply it by this. And then redo it, but take away these and then keep these guys here. Yeah, exactly. It's a mission. So instead of getting into this huge mission, I decided I'm just going to go ahead and make it easy. Make it the right way. First of all, 3 by 3 matrix, please remember 3 rows by 3 columns. Okay? And this is how easy it's going to be. When you're going to find the determinants of a 3 by 3, it's going to equal the 3 by 3 matrix that you were given plus, not plus, but right next to it, you're going to take these first 2 rows, or columns rather, and you're going to put it right here. So you're going to rewrite it. So you have the regular matrix that they gave you, and then right next to that matrix that they gave you guys, you're going to put the first two columns. You're going to repeat the first two columns. Okay? You're going to repeat the first two columns. No, you don't forget about anything. Remember, this is the 3 by 3. This is how you solve it. You write the 3 by 3 matrix, and then you write the first two columns right next to it. Thank you, my man. Okay, now, pay attention because this is easy, but it could be very confusing, okay? See this corner guy here? You're going to multiply all of these. Then you're going to multiply these three. Then you're going to multiply these three. And you're going to add them all together. Okay? These three values. Then you're going to go to this corner. You're going to multiply these three values times plus these three values and plus these three values. And you're going to take the blue sum and you're going to subtract it from the red sum. If you see on your notes, I made it a lot prettier, but I wanted to show you what this was, how this came about. So again, I have my regular matrix, and I'm going to add the first two columns right here. Then, I'm going to take this bottom corner, and I'm going to literally make a straight line so that I have A3 times B2 times C1 plus B3 times C2 times A1 plus C3 times A2 times B1. Okay? Then, I'm going to take this left top corner, and I'm going to again make a diagonal, multiplying A1 times B2 times C3. Then I take B1 times C2 times A3. Then I take C1 times D2 times B3. And then I take, and then I subtract them. Yeah, let me just make sure. Hold on. So, no, guys, yeah. It's my red minus blue. So, these guys minus these guys. Okay? It's red minus blue. But the best way to practice is to practice. So let's check it out. Find the determinant of each. Now, luckily, Mr. Morrow's nice, so I gave you a little hint. So for a 2 by 2, this is Mickey Mouse, guys. It's 15 minus negative 2, so my determinant here is 17. Make sense? Yes. Pretty simple. Now, for my 3 by 3, I give it to you again. You have your 3 by 3 here. Take the first two columns and repeat them. Okay? And basically, I'm going to do it a little bit differently. Instead of doing my blue first, I'm going to do my red first because it kind of throws people off sometimes if you do it backwards. So 1 times 4 times 2 is 8. 0 times negative 3 times negative 1 times 3 is 0. Negative 2 times 0 times 5 is 0. This happens a lot. Minus 3 times 4 times negative 2, that's negative 24. 5 times negative 1 times 1 is negative 5. And 2 times 0 is 0. So minus a negative 29. So this is 8 plus 29, which will equal 37. And that's how you find a determinant. What do you mean? Anything times 0 is 0, Papa. No, anything times 0 is 0, my man. So 0 times negative 1 is 0, and 0 times 3 is 0. Thank you for caring, man. You're human. I make mistakes. It's no big deal. Life is not determined by how many mistakes you make. I think that success is determined by how much did you learn from the mistakes that you made. We all make mistakes, guys. Let's continue, because there's not much left. Let's find a determinant. Okay, 15 minus 12. Done. My determinant is 3. Let's find a determinant. 0 minus 0 is 0. Done. Ha, done. Let's find a determinant. I got a 3 by 3. Take the first 2 columns and write them right next to it. Repeat them. 1 times 4 times 3 is 12. Plus 0 times 6 times 5 is 0. Plus 3 times 2 times negative 1 is negative 6. Minus 5 times 4 times 3 is 60. Negative 1 times 6 times 1 is negative 6. 3 times 2 times 0 is 0. So I got 12 minus 6, so 6 minus 54 will give me negative 48. Yes. And that's that. Does that make sense? Promise? Come again, sir? It's minus 60 minus 6 plus 0. So 60 minus 6 would be 54. Thank you so much for asking, sir. God bless you. Does that make sense, guys? Yes? Promise? Okay. Okay, now, I'm going to do it anyways just because I'm just stubborn. Real quick, let me just show you the usefulness of this, okay? I promise you, I won't test you on this, but I gotta just show you because it's just so cool. And I made such a cool little drawing here. I wanna show it off. Okay. So basically, it's a very selfish thing that I'm doing. Okay. Check it out here, boys. If I want to find the area of any triangle, okay? Sometimes we can't find the base and the height of a triangle. Sometimes it's an oblong triangle like this where no sides are equal. You don't have a right angle. You don't know the height. It's kind of impossible to find the area there. Not if you're using the determinants. The area of a triangle is 1/2 of the determinant of the matrix A. And matrix A is made the following. Triangle is made of 3 different points, right? Well, put your first point here, followed by a 1. Second point, followed by a 1. Third point, followed by a 1. Find the determinant, divided by 2. What is this crazy man talking about? Let's check it out. Let's just label this x1, y1, x2, y2, and x3, y3. No, it does not matter the order, okay? Because the area is still going to be the same. So, let's get my x1, y1, 1, 3, add the 1. Let's get my x2, y2, add the 1. Let's get my x3, y3, add the 1. Now, this is a 3 by 3. So, in a 3 by 3, we take the first 2 columns, this guy and this guy, and we write it right next to it. Is everyone with me before I continue? I know I'm going fast. Okay. Thank you, guys. So 1 times negative 1 times 1 is negative 1. Plus 3 times 1 times 5 is 15. Plus 1 times 9 times 8 is 72. Then I've got here 5 times negative 1 times 5 is negative 5. Plus 8 times 1 times 1 is 8. Plus 9 times 3 times 1 is 27. So, what is my determinant? Sorry, I went a little too high. It's going to be 86 minus 30. So, my determinant will equal 56. What's the area? Area equals 1/2 of 56, so that equals 28 units squared. Talk to me, boys. Sir? Can that be an extra credit? Perhaps, yes, maybe. But it's not that hard, is it? Yes, sir. I'm sorry, my brother? Okay, thank you very much. The question was, can you find the area of a square using this? No, and you wouldn't need a special formula for a square. Think about it like this. A square has all equal sides, right? So if they give you a square, it's going to be easy to find the area because it's side squared. But in a triangle, there's a specific formula. It's base times height divided by 2. You don't know the base, you don't know the height. But you do know the 3 coordinates of the points of the vertices. So you create your matrix, find your determinant, divide it by 2. I promise that's the area. Yes, sir. No, it would not be 30 minus 96. It's the top products minus the bottom products. Thank you, sir. Yes, sir. How would we be able to do it another way? Distance formula gives you the sides of all of them, okay? Okay, yes, that you could do that. You're talking about 5 times more work, but yes. You could find the midpoint here, right? And then from the midpoint, you could drop down a 90-degree angle, but you better make sure that 90-degree angle cuts that side in half, which is where you'll be a little bit stuck. But actually, no, you don't even need to do it in half if you have the whole thing. Then you find the distance from the midpoint to the 9, negative 1, which is the distance formula, and then you could do base times height divided by 2. Genius thinking, yes. But it's quicker if you just use the determinants. Okay? Now, let me just start with Cramer's rule, so that way tomorrow we kind of can just keep flowing, okay? So give me 1 second, let me pull that up. Okay, guys, now, determinants. We already saw how we use them for area. Now, we're going to see how we use determinants to solve systems of linear equations. Cramer's rule is used to solve systems of linear equations. The solution of a system of equations with 2 variables. Yes? I know I haven't posted the notes yet. That's why I said let's start together right now, pay attention, and then we'll continue tomorrow. Thank you. So, like I was saying, Cramer's rule is used to solve systems of equations. Okay? The solution to the system of equations with 2 variables, ax plus by equals e, and cx plus dy equals f, is the following. It's the determinant of x. How do you find the determinant of x? Pay attention. When I want to find the determinant of x, I'll be right back. All right, guys, sorry about all this confusion back and forth in the announcements. Thank you so much for your patience. You guys are the best. Let me explain something that's extremely important, though. When you're setting up these matrices, okay, to use Cramer's rule, notice what happens here. It's the determinant of x divided by the determinant of the original matrix. What does the determinant of x mean? Well, if you notice, I replace the constants with the x values. See how now it's EF and BD stays the same because those are my y's, right? And then what is the determinant of the regular system, Mr. Morrow? It's all the coefficients, not the constants, only the coefficients. For the y, okay, when I want to find my d of y, look at what happens here. My EF gets replaced with my y values. So I have my coefficients of the x, I have my EF. That's d of y. So if I say d of x, I replace the x coefficients with my constant values. If I find d of y, determinant of y, I replace my y coefficients with the constant values. And I divide both of them by d, which is just simply the determinant of the coefficients by themselves. You with me there? Talk to me, bro. Talk to me. Okay. See how I have E and F here where the X would be? And then see on the Y that I have E and F in the spot that the Y would be? Thank you so much, brother. That's why you guys are great, because you have guts to ask. And of course, Cramer's rule only works if and only if the determinant of the system does not equal 0. Okay? If the determinant of the system does not equal 0, this works. Now, in case you're wondering, why does that matter, Moro? Can I have a fraction with a 0 in the denominator? So that's what I mean. Now, this I know looks like Chinese right now. Let me show you how to do this, okay? Super simple. Let's solve the system 5x plus 7y equals 13 and 2x minus 5y equals 13. Okay, first things first, find the determinant d. Why? Because I'm going to divide determinant d to both the determinant of x and the determinant of y. So the determinant of d only works with the coefficients. So I have 5, 7, 2, and negative 5. So my determinant is negative 25 minus 14, which is negative 39. That equals the determinant of the matrix. Right? We're good? Okay. Now, let's find dx and dy. Determinant of x, remember, I'm going to replace the x's with my constants. So I'm going to have 13, 13, 7, negative 5. And that will equal 13 times negative 5 is negative 65 minus 91. Is that correct? Guys, yeah, so I think that is 156. Is that correct? Negative 156. Okay, so that's my d of x equals d of x. Now, my d of y. My d of y, I am replacing my y values with this 13 over 13, right? So I have 5 and 2 for my x, and then 13 and 13 for my y. 5 times 13 is 65 minus 26, so that equals 39? Is that correct? Yeah, 39. So that equals d of y. You guys with me here? So now, solve for both x, which is d of x over d, and y, which is d of y over d. So my x here is d of x, which is negative 156 over negative 39. And my y is d of y, which is 39 over negative 39, guys. So what's my solution here? I think that's 4, no? 4 on the money, negative 1. Now, you can check your solutions if you want. X is 4 and y is negative 1. X is 4 and y is negative 1. X is 4 and y is negative 1. Let's see. 20 minus 7, does that equal 13? 8 plus 5, does that equal 13? And that is how you solve using Cramer's rule for a 2 by 2. Tomorrow, we will learn how to do this for a 3 by 3. Thursday, we'll take a test. Thank you as always for your patience. You are the best. Have a great day, and I hope you learned a lot. Bye-bye.